So good morning, learner. Welcome to today's math lesson. Just to remind you, in our previous lesson, we dealt with the surface area of cuboids. Now today I want us to look at surface area of cylinders. But before that, I want to explain what a cylinder is. I know at your home you have even buckets or something that look like this. This is what we call a cylinder. And a cylinder, just like we saw in cuboids, a cylinder also has some faces. Let me talk about shapes in a cylinder. There are circular shapes, and there's a rectangle or rectangular shape. The reason I'm talking about circular shapes because it's not one, there are two. So if you want to know exactly what a cylinder is, I want you to look at the drum in your home, or even a glass. Look at a glass, the way it is made. That is an example of a cylinder. Though you will see that the glass is open, so we will explain what kind of a cylinder is that. So in this one, I want us to understand the shapes by getting this and dividing it into two, just like that. We cut it into two, and when you finally cut this into two, you will have something like this. You will have a rectangular shape, because if you cut this one and stretch it to look like an iron sheet, you will have something like that. Then you have removed the circular parts. So the circular parts are going to come down here. They are going to be there. There are two of them. We have the top circular part, you remove it, and the bottom circular part. Remain with this curved surface. The curved surface, if you cut it like this, you are going to form a rectangle. And that rectangle is going to have a length and a width. It's a rectangle which has a length and a width. Now, learner will be told to get the surface area. I've told you already this we call a curved surface. So, the rectangular shape, we call it curved surface. In a language that you understand, for mathematics, we call it curved surface. Because all this is going to come in the exam as what is the curved surface area of a cylinder whose measurements are given below. So we need to understand what the curved surface is. The curved surface is a rectangular shape. After you cut the cylinder into two and stretch, actually you cut it on once and stretch to form these two types of shapes. Two circular parts and the curved surface, which is a rectangle. How do we get area of this learner? That is the main problem that we are supposed to handle today. And it's very easy. Learner, we know how to get area of a circle. That one we are sure of. But then learner, we need to get the measurements, this measurement of this rectangle, because we are saying it's a rectangle. So the rectangle must have measurements. Must have a length and a width. That's why we need to have it. So how do we get the length and the width? Assuming our cylinder here was having a height, so this is called height. And assuming this height was simply 10 centimeters. So this height becomes the width of the rectangle. Take that, learner. So this is going to be 10 centimeters. So the width of the rectangle is the height of this particular cylinder. So we carry the width is and place where we have the width. Then learner, if we want to get now the length is all these curved parts. Remember, if you want a thread on this particular cylinder and you hold it somewhere and then measure that distance, it will be equivalent to the distance from this point to this point, because this is what was formed around this place. So if you stretch it, it forms this exactly. So for you to be able to get the distance, this distance, you can only get this distance by calculating the circumference of this particular circle. Because this circle was really fitting on this particular, remember this side, the one that we have cut and stretched, this side forms the length, and then this forms the width. You can see the width is here, and the part that was wound here is the one that we stretch to form the length. So that part is equivalent to the circumference of this particular circle line. So we get the circumference of this circle, and assuming our circle here had a radius of 7 centimeters, we can easily get the circumference. How big is circumference? Circumference is pi d. Pi times d. Assuming our pi in this case is going to be 22 over 7. Lana, our circumference is going to be pi 22 over 7 times diameter. How do we get diameter, Lana? We get the radius, we multiply that by 2. Because radius means from the circumference to the center of the circle. That is what you call radius. But if you stretch from the circumference through the center, you get what we call a diameter. And remember, Anna, when you are calculating the circumference, we get the diameter. We don't use the radius. So you must get the diameter, which is going to be a radius plus a radius. Because from here to here is 7. It also means that from this side to the other side is also 7. So 7 plus 7. That's why I'm saying 7 times 2 to give you a diameter of 14 centimeters. So, diameter of 14 centimeters. By 7, 1, by 7, 2. And that is going to give you 44 centimeters. So the circumference of this particular circle is going to be 44 centimeters. That circumference is going to be the length of that particular rectangle, because it's the same distance. This distance is the same as this distance. Because this circumference and this circumference, if you cut here and stretch, it will exactly fit here, meaning it's the same length. So from there, Anna, we have gotten the length and the width. Then we have the circular parts. Remember, we want to get area. How do we get area of a circle? Lana, how do we get area of a circle? Area of a circle is calculated by pi r squared. As simple as that. And so our area is going to be pi 22 over 7. Radius. What's the radius, Lana? The radius of the circle we said is 7. So square means 7 times 7. 7 multiplied by 7. That is what we mean by square. Square 7. 7 times 7. And so, Lana, how many circles do we have here? There are 2 circles. So we are going to multiply this by 2. Because if you say pi r squared is for one circle, if the circles are going to be 2, then you are going to add a 2 there. You are going to add a 2 there. To mean that 2 circular parts, we are getting the area. We are getting the area of 2 circular parts. Circle part A and B. So for one is pi r squared. If there are 2, they are going to be 2 pi r squared. Or pi r squared times 2, which is 2 pi r squared. Then this is going to give you 154 times 2 is going to be 308 centimeters squared. Now, we have the area of the circular parts. We want now the area of the rectangular part. The rectangular part, how do you get the area of a rectangle? Area of a rectangle is length times width. That's why we're looking for length and width. So our length is 44 centimeters, and the width is here, 10 centimeters. So this is going to give you 440 centimeters squared. Now, if you want the total surface area is going to be the area of the 2 circular parts, that is 308 centimeters squared, plus the area of the rectangular part. these two circular parts plus the area of the rectangular part, which is a curved surface. So this is going to be 440 centimeters square. And this, therefore, is going to be 308 plus 440 is simply 748 centimeters square. So the total surface area is going to remain 740 centimeters square. So now you have known how we've come from the circular parts, the curved surface, and later getting the area. Now, that is not what is important. The most important part of this is to know how to get the formula, because we need the formula. Every other time we will not be doing this, dividing the cylinder into two and be able to calculate that. We are going to develop a formula. Now, this is how we get the formula. The formula is going to be the area of the circular parts plus area of the curved surface. I want to take you back where we began. We began somewhere there. Area of the circular part, if it is a closed cylinder, we are assuming this is a closed cylinder. Closed cylinder has both circles, meaning that it's not open. But when you open one side, it remains with one circle. So this is a closed cylinder. So a closed cylinder is going to have this formula. If the cylinder is closed, it's going to give you this formula. The area of two circular parts, that's how we got the area of the two circular parts, because we see if it's closed, it has two circular parts. So you must calculate the area of those two circular parts. So the area of the two circular parts plus the area of the curved surface. Now I want to bring you back here. How did we get this length? By getting pi d. So we pick this pi d to replace here where we have 44 is pi d. And then this 10, what do we see the 10 is? The 10 is the height which was here, the height of the cylinder. Remember me drawing the cylinder there and showing you that this height of 10 is going to be transferred to be the wheel. So we are no longer picking the wheel because this is not a rectangle, we are not calculating a cylinder. So we are going to pick the height, and in this case, we are not going to pick the length, we are going to pick pi d. So plus pi d h. And how do we get this? By getting pi d, which is a circular part, the circumference of the circular part, multiplied by the height. Where is it land? Here. Length is represented by pi d times the width. The width now has changed to be height. So area is equal to pi d times height. When you multiply pi d times height, you get pi dh. So this is the formula of a closed cylinder. How we get surface area of a closed cylinder. So surface area of a closed cylinder is 2 pi r squared plus pi d h. As simple as that. If, for instance, the cylinder is open. Open means that you are going to have one circular part. So you don't need to have the two. You have one. So you are going to have 1 pi r squared plus, this is not going to change because this curved surface is going to be there. Even if you remove one circle, the curved surface is going to remain there. So plus pi d h. But later we don't need to write this 1. If the coefficient of a number is 1, we leave the 1. We don't write the 1 there. And so simply, we are going to get the surface area of an open cylinder by getting pi r squared plus pi d h. So these are the two formulas that we are going to work with in any question that we are given of a cylinder regarding surface area. So I want to give you examples. Then we are going to use formula. Lana, you say, I want to write the formula as well. Open cylinder. Let's begin with closed cylinder. Closed cylinder. The surface area is equal to 2 5r squared plus pi dh. Open cylinder which has only one circular part is going to be, the surface area is going to be pi r squared plus pi dh. Then the curved surface, because sometimes you can ask the curved surface only. The curved surface, remember I said, is the area of the rectangular part. So the rectangular part is this part. So curved surface area is going to be pi dh. So these are the formulas that are going to guide you through to be able to do any work that you're given about cylinders. I want us to move to a question so that we understand exactly what is it that we are doing. So I want to give you a question here. I want to mention one thing before I move to what I want to say, that I want to write it there. I will write it there. So let me just explain something here. So there is what we call a pipe. Now if you look at a pipe, I want you to look well if you have pieces of pipes at home. I want you to check whether it's open on both sides or one side is closed or is closed on both sides. If you look at it well, Lana, you realize that a pipe is not closed anywhere. So it's a through shape, meaning that it looks like this. If this is a pipe, then these parts are through, meaning that they are not there. So the circular parts are not there in a pipe. The reason why I'm saying that is because I've seen a question somewhere, and this one comes in an exam. You ask, calculate the total surface area of a pipe of this length, assuming our pipe is 21 centimeters in length and diameter is 14 centimeters. Do you know that there is a way we can be able to get the total surface area? You realize that the two sides are not there. This and this are not there. Meaning that we are only calculating the area of the curved surface. So, Lana, when you are calculating the pipe, let me write it here. When calculating pipe, you use formula curved surface area, which is going to be pi d. If they have mentioned that the shape you have to calculate the surface area is a pipe, don't waste your time, learner, looking for the circular parts. They are not there. Use this formula, pi dh. Pi dh will give you the area of the curved surface, because it has only the curved surface. This one only. It doesn't have the circular parts. So in case this is a pipe, and we are told calculate the surface area. This is going to be, surface area is going to be pi dh. Simple as that. And so surface area is going to be pi 22 over 7. Diameter, what's the diameter? 14 centimeter. And the height becomes the length. If they mention the length in the question, that they tell you the pipe is of this length, that becomes the height. So the height is going to be this one here, 21 centimeter. So by 7, 1 by 7, 3. This is going to be 66. You multiply that by 21. Get 6, get 6. You get 12, got 1, 12, 13. 6, 8, 3, 1. And that is going to give you, the surface area is going to be 1,326 centimeters squared. Remember, area is given in square units. So you must, at the end of the day, write the units as square units. So we are done with that, learner. I want to give you 2 more examples before I give you a number of questions here to be calculated. And I write the questions here. What is the surface area? What is the surface area of a cylinder whose height is 20 centimeter and radius 14 centimeter. So Lana, when you get a question like this, it's very important for you to be able to draw. So let us draw the cylinder here. The cylinder is going to look like that. You are told that the radius is 14 centimeter and the height is going to be 20 centimeter. So you come and say surface area is equals to, because it's a closed one, 2 pi r squared plus pi d h. Therefore, the total surface area is going to be 2 times 22 over 7 times, we write down here so that you understand. So the total surface area is going to be 2 times pi 22 over 7. The radius is 14. So radius squared 14 times 14. And then we put that into a bracket plus pi 22 over 7 diameter. The diameter is going to be twice this radius. So 14 plus 14, 28. Then the height is going to be this 20. Remember that when we talk about diameter, you're going to add this and this one to give you that. So by 7 1 by 7 2, this is going to give you 44 times 2, which is 88. 88 times 14, 2 carry 3, 32, 35, 8, 8, 2, 3, 11, 12. So this side surface area will be equal to 12.2 centimeters squared plus on this other side by 7 1 by 7 4. This is going to be 88. 88 times 2 is 176. So 176 plus this 0 here, centimeters squared. So the total surface area is going to be this 12.2 plus 1760. So 1760 here, you get to 992. So it's going to be 2,992 centimeters squared. So at the end of the day, you must add both sides. There's an addition sign here, Lana. Very, very important. Meaning that you're going to have a bracket. That's the reason why I'm putting the bracket, because this and this are not equal. And so I'm doing one part and adding to another part. That's why you see these two brackets. After that, after creating this, you open the brackets. Now what you get here, you add this, what is here. I want to write a second example. This is going to be the last one before I give you the work. Question number 2. Calculate the total surface area. Of an open cylinder with a height of 10 centimeter and a diameter of 21 centimeter. So we are to calculate the total surface area of an open cylinder. This is very, very important. Open cylinder with a height of 10 centimeter and a diameter of 21 centimeter. So now I say drawing is very, very important to be able to indicate the measurements. And therefore, our diameter here is 21 centimeter, but the height is, of course, 10 centimeter. And so, which formula are we going to use? We are told it's open, so one circular path. So surface area will be equal to pi r squared plus pi d h. One circular part, because it's open. So the first part is the area of the two circular parts, and the last part is the part of the curved surface. But here we have only one circular part, so we get pi r squared. So this is going to be pi 22 over 7 radius. The radius is going to be diameter over 2. So you can just say diameter over 2 times diameter over 2. Or if you divide this, you get 10.5. So the radius is going to be 10.5. So you take 10.5 times 10.5. But for me, I've used 21 over 2 times 21 over 2. It's the same thing. I don't want to work with the decimals. That's why I'm putting 21 over 2. This means 10.5 times 10.5. Then I close that, plus 22 over 7, the diameter is going to be 21, and the height is going to be 10. I close that again. So this is going to be 7.1 by 7.3, by 2.1 by 2.11, then by 2.1 by 2, 5.5. So I have 5.5 times 3 times 21. 21 times 3 is 63. So 63 times 5.5, but I know I have one decimal place. So this is going to be 5 times 1, 30 31. Again 5 31. So this is going to be 5, 6, 4, 3. But one decimal place there. So this is going to be 346.5 centimeters squared. Then I work on the other side by 7.1 by 7.3. This is going to be 66. 66 times 10 is 660 centimeters squared. So I'm going to add the two. 660 plus 346.5. It's going to be 5.60910. So this is going to be, the total surface area is going to be 1006.5 centimeters squared. Very simple, learner. If you follow the formula, you are going to enjoy mathematics because the formula is going to guide you to be able to do every other question. So with that, learner, I want to give you an exercise here. So that now, every time you're going to do, you write those formulas first in your book, so that after reading a question, you can identify which formula am I going to use. Is it 1, 2, or 3? So I'm going to give you work from what we have done. So exercise 81, and 82. Exercise 81, exercise 81, and exercise 82. All these concern cylinders. You're going to find them from where we left our previous lesson. Just if you turn the pages, you see exercise 81 and exercise 82. So learner, I want you to do that work with a lot of composure and ensure that every time you are calculating a question, you have the formula at hand. That is what we call knowing mathematics. Formulas, without formulas, you can never get anything in mathematics. But with formulas, you can get everything. So until next time, I want to wish you well. Stay safe at home. Continue being busy. And may God bless you very much. Thank you and God bless you.